All right. First assignment on con is going to be this one, unit circle. All right. So unit circle. Here's what a unit circle is. This whole unit's going to be about trigonometry. All right. So here's what a unit circle is. Let's do this. Take a line. Just draw it from there to there. All right. What's that called? A radius, right? So let's pretend the radius right now is 1. Everybody got it? Radius is 1. Now, if that's true, we can draw that same line anywhere on the circle, right? So let's put it like right there. That's still 1. Now, let's say I wanted to know a little bit more about where that line meets the circle. All right, so let's say I wanted to figure out 2 things. What's the x coordinate and what's the y coordinate? So we can do that using trigonometry. Let me show you to take you back to your days of geometry. If I trace over and I trace down, what kind of shape have I formed? Triangle. What kind of triangle? Right triangle. Very good. Now, in a right triangle, there's a formula, and it's or a theorem by a guy named Pythagoras. Now, Pythagoras is his name. The theorem is called the Pythagorean theorem, right? The Pythagorean. It has an N on the end. Some people mispronounce it as Pythagorean. It drives me nuts. Please don't sound like an idiot, okay? Pythagorean theorem by Pythagoras. Now, here we go. Distance sideways is measured by an x coordinate, right? What's vertical distance measured by? A y coordinate, right? Now, we're also saying that this is on like a coordinate plane at the same time. I failed to mention that. All right, now, if that's true, what can we say about the relationship here? Well, we could say this, and we could say Pythagorean theorem. We could say x squared plus y squared equals 1 squared, right? Remember that? And we'll get back to this later on in this unit. All right. Now, the other thing we can say in right triangles dates back to your days in geometry. And this kind of acronym. It's up here on the wall, up there, right? SOHCAHTOA. SOHCAHTOA references the relationship between an angle and the sides in a right triangle. Now, how is this useful? Well, if we know this angle, or let's say this is any angle, right? How can I define this side? Well, I could say a few things. I could say the sine of the angle, this comes from this part of SOHCAHTOA, is the opposite over the hypotenuse, right? What's the hypotenuse? 1. Now, if I simplify that, that really just says that the sine is equal to the y coordinate, right? Y divided by 1 is the same thing. If I do the same thing with the cosine, right here, cosine is adjacent side over hypotenuse. Cosine is the x coordinate. Let me kind of flip-flop and put them in order. So if we know an angle on the unit circle, we call it the unit circle because when you're referencing anything in measurement, a unit means 1, right? Literally the prefix UNI means 1, right? This is a unit circle. If you have a unit circle and you know an angle, that means you also know the location of any point on the circle because you can use the cosine and the sine to do that. So in short, this proof is just a fancy way of saying the x coordinate is the same thing as the cosine, and the y coordinate is the same thing as the sine. That's what that means. Now, cosine of what? Cosine of the angle. I need to really write that in there. It's a little sloppy, but that's what it is. So it brings us to our first question of the day, right? Now, you need to memorize this. You will not be able to write that down and use it for notes. The x coordinate's the cosine, the y coordinate's the sine. How can you remember? Well, X and Y are in alphabetical order, right? Please agree with me with a nod. Okay, thank you. Cosine and sine are also in alphabetical order, right? X and Y, cosine and sine. We used to say this really stupid thing in high school. I used to say sine and cosix. It makes no sense, but that's how I remembered it. Sine and cosix. If you spell it out, SINY, sine and cosix. It means nothing, but that's how I've remembered it for 20 years. Okay. Yeah, it's been that long ago. Show your faces. Okay. Anyway, here we go. Points A, B, and C are plotted on the circle. The question down below says, which of the coordinates is equal to the sine of 200? Which of them is equal to the sine of 200? Choose one answer. Okay. Now, 200 degrees, let's think about that on a circle. Where is that? Well, we start measurement from right here. This is 0. Right? Here's our unit circle. 0 degrees is right there. What's this? Yep. And then what's this guy? 90. Let's keep going. What's that one? 270. Very good. So using those as rough kind of landmarks, where's 200? What quadrant? Third quadrant, right? 200 is about here. Yeah, ish, something like that. 200 is about there. You would also know that right here, halfway is what? That's 45. What's halfway there? 135. This would be 225, by the way, right there. And then this one would be 315, right? Halfway marks, 45 degrees, right? Halfway between 0 and 90. So 200 is roughly there. The question is, which of the following is equal to the coordinates for the sine of 200? Which of the coordinates is equal to the sine of 200? Now, 200 degrees is about here, right? That's what we just said. And we're talking about sine or cosine? Sine. So who remembers? It's the y coordinate, right? So we're looking at point B, and it would be the y coordinate of point B. What would the x coordinate of point B? What would that be? Equal to? Yeah, this is the sine of 200. Nope, not 2,000, 200. This would be the cosine of 200. Point A, this would be the cosine of whatever angle that is, right? Maybe like 135 because it's the x coordinate. If it was the y coordinate, it would say sine of 135. I'm just guessing on the angle, all right? C would be an angle that would be bigger than 270, maybe like 300 or something like that, right? So this would be the cosine of 300. This would be the sine of 300, like so. Okay, so y coordinate would be, let's do the next one. Ready? So here's a point. It says, what is the value of the y coordinate of point A? Sorry, that's probably not large enough. There you go. What's the value of the y coordinate of point A? Now, this is 15 degrees. Let's try to do this without using the multiple choice. If that's 15 degrees up from there, Dean, what's this angle right here? Not the 15, but this location right here on the circle. Remember, this one's 0. What's this? 180. Yep. So if that's 180 and it says go that way 15, that means we have to take 15 away. Yeah, so 165 is the angle. The angle is here, right? 165. It's a rotation from there. All right, so 165, the question is which of the following is the value of the y coordinate? Well, it would be the sine, right? It'd be the sine of 165. Okay, let's do another one. A, B, and C are on the circle. What angle is A? Tell me now. What about B? What's C? 180. All right, very good. All right, which of the coordinates is equal to the cosine of 180? 180 is here. That's what you just told me. And it's asking for the cosine. Yep, we know that the x coordinate is equal to the cosine, right? So we should be looking for the x coordinate of C. Okay, easy enough. All right. Let's pause here. I'm going to assign this one. You guys can work on that. Okay. All right. So the next assignment is going to talk about a different way to measure angles, right? So on all the examples that we just did, we measured an angle in degrees. Now, if you remember back to geometry, you probably touched on this ever so briefly. You guys ever heard of radians? You remember the term radians? All right. So if not, then today's your day. All right. So what we're going to do here on this assignment is we're going to convert. There's a different way to measure angles instead of degrees. All right. Here's what I'm going to point out to you. All right. So really quick, imagine you are in the middle of a circular track. All right. And you have a friend that is also walking on the track. You're in the middle. Here's your friend. Now, if you tell your friend to walk, let's say, 100 feet, or let's say a half of a lap or something like that, right? They could do that, couldn't they? Right? Or let's say you ask them to walk a certain distance, like 100 yards. Well, they could just count while they're walking. You know, a step is about a yard and so on. They could estimate it pretty closely, right? And they would do this and they'd count, about 100 yards, whatever that would be. Depends on how big the track is, right? Now, the question that would be hard for them to do would be to say, imagine you're in the middle. It's easy for you to see where an angle like 60 degrees would be, right? You can kind of say, all right, here I am. Here's 90. 60 would be somewhere in the middle for you in the middle, right? But what if you are the person on the track? If you're on the track and I ask you to walk 60 degrees, that would be tougher to visualize, right? Because you can't see the start and the end all at the same time, can you? You get what I'm saying? It's a little tougher. So what if instead of measuring angles from, the observer in the middle's point of view, what if we measure an angle in terms of distance? All right. So like this. So what I've drawn right here, the highlighted part is called 1 radian, right? And actually, that's how we would label this angle, 1 radian, RAD for short. And why is it called a radian? Well, that's because if this distance is 1, sorry, let me just erase all that. If this distance is 1, well, isn't the other radius also 1? Yeah. If we walk a distance that's equal to the radius around the edge of the track, then this is called 1 radian. It's called a radian because the angle is based off of the radius. That's right. Yep. If this is 10, then so is this. 1 radian would mean that I walk 10 whatever, right? 10 feet around this circular track, or 10 meters, right? That's what 1 radian is. So if I kept going, now watch this. This is fun. If I kept going, I'm just going to estimate. This would be another radian, wouldn't it? So let me erase this real quick. Let's say we're on our unit circle again, where the radius is 1. That means this distance from there to there is also 1. Let's say I go another radian. It would be there-ish. I think my second one's a little large there. But anyway, that would be another radian. And if I kept going, that would be another radian. And then about there, and then about there. Now, it just so happens that if I trace my radius over here to 180 degrees, this number for the number of radians in a half of a circle turns into this, 3.14159. You get what I'm saying, right? So what does that mean? That means 180 degrees is equal to pi radians. It's a fun little consequence, all right? Now, what it really comes from is the circumference of a circle. Circumference of a circle is this, 2 pi r, right? So what if the radius is 1? That means the circumference is 2 pi, which is saying the distance all the way around is 2 pi, right? But that's the way we measure radians. Radians are a distance. It's a distance around. You're on the track. You're walking around. That's a radian, right? So a half of a circle is 180, and a half of 2 pi is 1 pi, right? So there's two conversions you can use. 360 is 2 pi, or 180 is pi. That's your conversion. It's a different way to measure an angle. So when we get to the first question today, this one says, convert the angle. You can write this one down. It's a good one to write down. Convert the angle theta equals 14 pi over 9, 2 degrees. Change that into degrees. Well, we just said a second ago that pi is equal to 180. So there's a couple ways to attack this, but this is the easiest way. Pi is 180, right? So there's the dimensional analysis kind of way where you could say, oh, this is radians. Let me set it up so radians cancels out and I'm left with degrees. Or you can do it this way, right? So pi is 180, right? Well, check it out. Let's do this. Cross it off and make it what? 180. So that now we can just do this. Let's do 14 times 180 divided by 9. It's okay to use a calculator. Here we go. It says express your answer exactly. All right, so 14 times 180. Let's divide that by 9, or 280. Okay, so this is in degrees. The next one, we're going to go back the other direction. We're going to say, let's take 260 and turn it into radians. Now, up here, what did we essentially do? Well, essentially, we cut out the pi. Follow this visual here. I need your eyes up here. We cut out pi and multiplied by 180, right? Down here, we're going the other direction. So instead of multiplying by 180, we're going to, let's divide by 180. Let's do that first. 260 divided by 180. It's that weird number. If you have a calculator, we need to turn this into a fraction, okay? So that's not going to cut it. We need to answer exactly like it says. So we need to turn this into a fraction. So let's reduce this really quick. One way to reduce is cross off at 0, right? It's like dividing them both by 10. Then you can divide them both by 2, right? So 26 divided by 2, 13. 18 divided by 2, 9. Now, we're not done yet because, like I said, up here, we did two things. In the first example, we did two things, and we're working backwards now. So up above, we crossed off pi, and we multiplied by 180, right? Now we're working in the opposite order. We divided by 180, and now we need to add on the pi. This is an example of an angle measured in radians, right? So 13 over 9 with a pi on the side. You can write it like that. You can also write your answer with the pi on the top. Both of those things mean the same thing. All right, every single one of those is either convert radians to degrees, which is like this, or the other direction, where we simplify by dividing by 180 and multiply by pi. All right, now, before I move on, the last assignment today is this one right here. Hang on, where are you at? So it's the same unit circle that we had before, but now it's in radians. So what you're going to have to do is convert. You might have to convert. For example, it says, which of the coordinates is equal to the cosine of 3 pi over 4? Well, you don't have the experience yet to know where 3 pi over 4 is. Here's what it means. It means that it's 3/4 of pi. Remember I said you could write the pi on the top or off to the side? Remember that? All right, now, who remembers where pi was? What degree is pi? Pi radians is the same as 180, right? So this is 180, but it's also pi. So where's 3/4 of that? B, right? Now, you could work it out that way. Some of them get tough to handle like that in your brain. So let's convert it. So let's cross that off and take it times 180. All right, so 3 times 180 and then divided by 4. 135 degrees. So now once we've converted it to something we're more familiar with, it's just like the problems we did earlier, right? So let's go to 135. 135 would be past 90, but not yet to 180, right? We're still at B. The question then says, what's the cosine of that? Well, cosine is X or Y? X. So we're talking about the X coordinate of B. All right, so this is just the same as the previous assignment. It's just in radians. You might have to convert. Deal? All right, let's do it.